In this demonstration, we'll take a look at how to use Wireshark to perform network analysis. Wireshark is an example of a network sniffer that can be used to capture network traffic and analyze that network traffic. You can download Wireshark from wireshark.org. I've already got Wireshark installed, so I'm going to launch it by double-clicking on the Wireshark icon. Once Wireshark is launched, you can see down bottom here that it does show our different network adapters, and you can choose which network adapter you want to capture traffic off. Here's my Ethernet adapter. You can see there is some network activity there, so that is the adapter I want to use. You can also hover your mouse over it, and you can see a little tooltip pop up that shows the IP address of that interface. So that's 10.0.0.1, which is the interface that I want to capture traffic off. So I'm going to double click on the Ethernet interface, and it starts capturing network traffic. Now what I'm going to do is I'm going to switch over to a client system and generate some network traffic, and then we'll come back and analyze that traffic. So I'm on my network client. What I'm going to do is go to a command prompt here. So I click on the start button and type CMD to go into a Windows 10 command prompt. Once in this Windows 10 command prompt, what I'm going to do is generate some network traffic. And in this example, I'm going to create some FTP traffic for us to analyze. So I'm going to do FTP space and then the IP address of the FTP server. The FTP server sees that authentication is required, so it prompts me for a username and password. So I type in the username of administrator, and it says that a password is required, so I type the password in. Then it says that I'm logged in. Perfect. If I want to view a list of files that exist on the FTP server, I can use the ls command. And I can see here there is one file called clientlist.txt. So if I want to download that file, what I can do is use my get command in FTP, and I can do get clientlist.txt. You can see that the transfer is complete. It says that it downloaded 99 bytes within a certain amount of time there. Looks like 3 seconds. Perfect. Now I'm ready to quit my FTP session. And notice that I'm back at my command prompt in Windows. Now, when I use the get command, it basically downloaded the file in the folder that you were in when you entered into the FTP session. So I was in the folder c:\users\student. If I do a dir there, I should now see there's my client list.txt. Perfect. So let's switch back to our monitoring system and let's analyze the packets and see if we can see things like the FTP username and password and the contents of the client list file. Okay, we're back on our monitoring system. The first thing I want to do is stop capturing network traffic, so I hit the stop button up top here. Now that I've stopped capturing network traffic, you can see our different packet numbers. So I've got like 460 packets that have been captured. So up top here, this is your packet list frame. You can scroll up and down and scroll through the packet. So I'm going to go to the top portion and start at packet number 1. So the idea here is that when you select a packet, like packet number 1 is highlighted, it then shows you the packet details down in our details pane here, and it shows the hexadecimal contents and the ASCII contents in the hex pane and the ASCII pane. So those are your 3 different areas. So what I'm going to do here is I'm going to scroll down and look for our FTP traffic. Now the FTP traffic is going to be TCP traffic at port 21, destined for port 21. So I'm actually looking for TCP packets here. So I'm scrolling down and here's a TCP packet. Now when I look at this packet, I can see in the info column gives you kind of critical information that you can use to kind of quickly identify what the purpose of the packet is. Here they're showing this 50651 with an arrow going to 21. Those are port numbers. So this is the client system sending traffic to port 21 on a server system. Now, I don't know that 100% yet, but just so you know, that's what the 21 is. That's your FTP traffic. Now, in this example, when I look at this FTP traffic, port 21, you can see that it's got the SYN in brackets. And then down below that, we have our SYN-ACK, and then we have our ACK. So this is the three-way handshake, the TCP three-way handshake of a client machine connecting to the FTP service. So that's a very critical packet. Now, when you take a look over here on the left, you can see the source IP address of the client, and you can see the destination IP address as well. So I can see here the source IP address of the client is 10.0.0.6 with traffic headed to the server at 10.0.0.1. You can see here in the next phase of the three-way handshake, the server is sending to the client the SYN-ACK packet. And then finally, the acknowledgement, which is the third phase of a TCP three-way handshake, is coming from the client going to the server. Notice after the three packets that are the three-way handshake, we then have an FTP packet. And this is basically the server coming back with the FTP banner saying it's a Microsoft FTP service. Then what's going to happen is down below here, we should see, there's a lot of different packets here. We should see when I highlight the protocol column for FTP, so as I scroll down, even though there's a bunch of DNS packets there, I'm ignoring those because that's not the type of conversation that I'm trying to analyze right now. But I can see here that we do have another FTP packet, a few packets down. So it looks like packet number 190 is the client is sending to the server a user space administrator. So this is the client logging in. So I can see the username that somebody's logged in as. Then the server comes back with a password required message. And then eventually I should see the actual password. So if I scroll down to my next FTP packet, right, we can see the password is pass space, capital PA $$W0RD. So that's somebody typing their password in. Now the user is logged in. That's a status message coming from the server going to the client, right? After that, then we should see an FTP packet where we're retrieving a list of files. So here is the client, 10.0.0.6, sending to the server an NLST, that's the ls command, right? Asking for a list of files. And then we should see some FTP data, which is going to be the list of files itself. So there's our FTP data. So from the server coming back to the client. Now, when you look at the FTP data, what's important is you can look down bottom here in the detail of the packet, and I'll look at this top section here in a second, but notice that we do have some line-based data, right? If I expand that out, it's basically coming back and saying, oh, you've got a client list.txt file. Now, one thing I want you to notice is that when I select a piece of information here in our detail pane, notice that it highlights that information in the hex pane and it highlights it in the ASCII pane, which is kind of nice. Now, I don't understand all that hex data, so that's why Wireshark has this detail pane, so that you can just look at the packet details. When you select a packet, you just analyze the traffic by looking at these packet details. You don't have to convert that hexadecimal data to ASCII data. Perfect. So here I can see that a user asked for a list of files, and they get a list from the server, client list.txt. Now, somewhere here, if I keep scrolling through our packet capture, so there's FTP data, we should see the command of get being fired off. which is the retrieve command underneath the scenes. So there it is there. So there's FTP data, a request for, I want to retrieve client list.txt. So that's the client at 10.0.0.6 sending a command over to the server that says, I want to retrieve client list.txt. And then we should see a response come back with FTP data, which is the client list. So again, if I highlight the FTP data, if I select that packet, so the server is sending to the client, and I look at that line-based text data, there's the contents of the text file, which is kind of crazy. But because we're using FTP here, and FTP is an unsecure protocol, it's not encrypting the communication. So anybody that can tap into that communication can see the data. Now, before we go any further, let's take a look at when you're highlighting a packet. So I now have packet 273 here. I can see the source IP address, the destination IP address. I can see the protocol, which helps me kind of understand the conversation a bit. And then the info column that gives me a little bit of detail. But a lot of your packet details are here in the details section. So just to give you a summary of some of the pieces of information we have here, if I expand out the frame section, in the frame section, you'll get information like the size of the frame, so how big it is, how many bytes, right? And also you'll get date and time information on when that frame was captured. Then if I collapse that, in the Ethernet section, you'll get your source and destination MAC addresses. So in brackets there's the source MAC address and the destination MAC address of the network cards that are communicating. So that's very interesting. And then if I collapse that and I expand out the next header, this is the IP version 4 header, where you can see all the fields that exist within the IP4 header, including the source IP address and destination IP address, right? So when I look at it, here I've got the source address is 10.0.0.1, destination address is 10.0.0.6. So the source and destination address are fields within the IP header, but what Wireshark does is that's pretty critical information. So Wireshark shows it as its own separate columns in the summary pane up top there. So that's very interesting. I can also see things like the time to live field. So the IP protocol uses a time to live field to prevent packets from running around on the network forever. Basically, every time the packet passes through a router, it decrements the time to live by 1. And once the time to live is set to 0, then the packet is removed from the network. The point here is that when you're analyzing network traffic, you learn default values used by different platforms. So for instance, the time to live value is set to 128 on Windows systems by default. Most Linux systems will set the time to live to 64 as a default. So my point is when I'm analyzing the traffic here, I'm also building a profile of the person that generated this traffic. So I'm looking at this saying, okay, whoever this person is, they're running a Windows system. Now, keep in mind, they could spoof that information, so they could customize the packet and set their own time to live to try to hide that kind of detail. But that's just one example of a default value that's set in your different fields. And a lot of times we use that as security professionals to help build profiles of hackers and kind of try to make some sort of guesstimate as to, what they're using as a system. So that's in our IP header. You have your source and destination IP address. And then we have because we're using TCP here as a protocol instead of UDP, if you expand out the TCP header, you'll see your source and destination ports. So this is where you'll see your source port or destination port of 21 for FTP, 20 for FTP data, which is what I'm looking at here. But also if it's a website, it'll be 80 or 443 and so on. The destination port here is the browser. right? So the FTP server is sending data to the web browser that the client is using, and that web browser has randomly selected a port number of 50,653. Now, one last thing that I want to do here is I want to show you how we can filter this output. So when you're looking at network traffic, there's going to be a lot of packets that are captured. So up top here, we do have a filter, a display filter that you can put in place. And there's a number of ways that you can filter traffic. So for instance, you can filter by the IP address. So I can write a condition here that says ip.address ADDR equals double equal sign 10.0.0.1. And I can hit enter. And what it's doing here is it's filtering out all of the packets so that you're only seeing packets that involve 10.0.0.1 as being the source IP address or the destination address. Now, in my example, that's all I have. But if I was capturing traffic on a live network, you may have packets from all kinds of different systems. So when you're trying to analyze traffic for a given system, this could be a very useful filter. And notice that the filter is showing a green bar in the background. That means the syntax is correct. So if I was to backspace over that, notice that it turns to red. It's showing that my syntax is not correct or is incomplete. You can also remove the filter if you go over here to the right and hit the red X or the X that's over there, and that will remove your filter. Now so a lot of times when I'm analyzing traffic, I'll filter by the IP address of the system I'm trying to monitor. Or the other thing is a lot of times I know what type of traffic I'm looking for. So for instance, if I'm looking for just FTP traffic, I could type the protocol of FTP here and then hit enter. And what you'll notice is that it filters out. I mean, I had a lot of DNS traffic that was captured, and notice that now when I scroll up and down, I don't have any of that DNS traffic. It's all FTP traffic that I now have. So there's the FTP banner coming back. Here's me logging in with the username of administrator. There's the server prompting me for a password. There's me typing a password. There's the server come back and say, great, you're logged in. There's me asking for a list of files and so on, right? What I am missing here though, which is unfortunate, is I'm missing the FTP data. So for instance, when I'm asking for the list of files, we're actually getting the transfer complete, but I'm not actually getting the list of the actual data that was delivered from the server because that's in a different protocol. That's in the FTP data protocol, not the FTP protocol. So what I can do here is in your filter syntax, you can use and or statements. So I could do 2 ampersands for an and. That's not what I want to use. I want to see packets that are using FTP or, so 2 pipe symbols is your or syntax, or FTP, and notice that they're showing me options as I type. Perfect. So here I'm putting a filter in place that says, show me any packets that are FTP or FTP data. And notice now I have some FTP, but I also have some FTP data, which is great because that means I'm seeing the client list and in this case, I'm seeing the contents of the actual file itself. So that's very useful. So you can filter not only by, things like the IP address, but you can also filter by protocols. And there's lots of different fields. Basically, any of these different fields that exist, you can filter by that. Now, I'm going to get rid of that filter. The other thing that I wanted to show you here, if I can find it, is my 3-way handshake. Let's find my 3-way handshake. Here it is here. Okay, so this is my 3-way handshake with port 21. What you can do in Wireshark is you can right-click on a packet and you can say, I want to follow the entire stream of data. So instead of me scrolling up and down and trying to find the next packet, again, because I am getting a big mixture of traffic, so you can see in the background there, I've got some DNS packets on the screen. Instead of scrolling around, you could either put a filter in place, which is very useful, Or you could say, I want to follow this TCP stream, which means I want to follow this conversation. And when you do that, it opens up a window and it shows you the core phases of that conversation. So there's that FTP banner. There's me logging in with a user administrator. There's the server come back saying you need a password. There's me typing the password. There's the server come back saying you're logged in. There's me asking for the list of files, right? And there's the transfer complete, but notice that I don't actually see the actual data that was delivered, right? So this is very useful, right? But it's also useful to be able to filter the list of packets, and I can close that filter that was applied. Filter the list of packets by protocol or IP address. So in this video, you learned how to analyze network traffic with Wireshark.